Hey guys, in this video, we will learn what do acids and bases have in common.
When an acid is dissolved in water, it dissociates the hydrogen. For instance, hydrochloric acid gives hydrogen ion and chloride ion when it is dissolved in water. This dissociation of hydrogen ion in the aqueous solution is the common property of all acids. Now let me ask you an interesting question. Do you think that all compounds which contain hydrogen are acidic in nature? Let's perform an activity to find out. We set up an apparatus like this. Within a beaker, we have a rubber cork and two iron nails fixed on it. And we connect the nails to the two terminals of a battery. We also have a bulb and a switch connected in series. At this point, the loop is not really completed as rubber is a poor conductor of electricity. Now let's add dilute hydrochloric acid to this beaker. What do you notice? You will see that the bulb will start glowing, which means that the current starts flowing in the circuit. Even if we'd put sulfuric acid in place of hydrochloric acid, the bulb would have glown. Now we empty the beaker, clean it, and add glucose solution to it. Why are we trying out with glucose? It's because we want to see if all compounds with hydrogen are acidic. Does the bulb glow? No, it doesn't. Even if we add methyl alcohol to the empty beaker, the bulb wouldn't have glown. It proves that these compounds are not acidic even though they contain hydrogen. It's because they do not dissociate the hydrogen ion in the aqueous solution. What about bases? Should we try repeating the same activity with bases? A base dissociates hydroxide in water, which is responsible for the basic behavior of a compound. For instance, when sodium hydroxide is dissolved in water, it dissociates hydroxide ion and sodium ion. The anions carry electric current in the solution, and hence the bulb will glow in this case as well. A base shows its basic character because of dissociation of the hydroxide ion.
What happens to an acid or a base in a water solution? Do acids produce ions only in aqueous solution? Let us test this.
See, to prove that acids produce ions only in aqueous solution. Okay, so that means acids will produce ions only in aqueous solution. So let us see why only in aqueous solution. Okay, and the materials required for this are a dry test tube, concentrated sulfuric acid, rubber cork, delivery tube, blue litmus paper, sodium chloride crystals, water. Instead of water, you can take wet litmus paper also. So dry litmus paper is needed and then wet litmus, blue litmus paper is needed. So if you take the blue litmus paper, so afterwards you just dip it in water and you can use it as a wet litmus paper. Okay. So now we'll go through the experiment. First, let us have a look at the materials required. This is the rubber cork and this is the test tube, dry test tube, and a small amount of sodium chloride crystals, and this is the delivery tube, and this is a concentrated sulfuric acid. So the bottle containing concentrated sulfuric acid, and this is a blue litmus paper. I already told you that some water is needed, otherwise you can take a wet blue litmus paper. So you need dry blue litmus paper as well as the wet blue litmus paper. Okay, right. Now we'll go through the experiment. Now we'll start the activity. So first of all, you have to take a clean dry test tube we need a clean dry test tube. This is a dry test tube. It should be a dry. If it is wet, you just clean it and then make it dry. Right. Now to this test tube, we have to add some amount of sodium chloride crystals. See here, I am taking about 1 gram of sodium chloride into it. So you can take more or less of it. So you place it in the some test tube. So this is a sodium chloride, right? So we have taken sodium chloride crystals in the dry test tube. Now we have to add the concentrated sulfuric acid. Okay. See, already we have taken sodium chloride crystals in the test tube. Now we are going to add concentrated sulfuric acid. So take some amount of the concentrated sulfuric acid into the test tube. We have to add few ml of concentrated sulfuric acid. See, this is the bottle which contains the concentrated sulfuric acid. Now we are pouring a few ml of the concentrated sulfuric acid into the test tube. Okay. See, we have poured concentrated sulfuric acid into the test tube. So here, this is a concentrated sulfuric acid. Because it is concentrated, we should be a bit careful. This is the precaution we need. So we have to wear gloves while using acids. Okay. So why? Because if it is a concentrated one, if it spills on your hands, it will have a itching sensation and your skin gets burns. So you should be very careful while using concentrated acids. So wear gloves while using the concentrated acids. Okay, right. Just now we have added concentrated sulfuric acid to the test tube. Now we'll fix one hole rubber cork to the test tube. So we have to fix a one hole rubber cork to this test tube. See, this is the rubber cork. Right, it is fixed to the test tube. So this is the rubber cork. It is having one hole in it. Okay. Okay, we have fixed the rubber cork. Now let us fix a delivery tube to the one hole rubber cork, and then we'll keep the whole arrangement for some time. Why? Because here we have added sodium chloride crystal and then concentrated sulfuric acid. So in between these two, the reaction will take place. Okay. So first we'll fix the one hole rubber cork. Already we have fixed it, and then we have fixed the delivery tube to it. And this delivery tube is also called as a side tube. Okay, you can call it in either way. Now we'll keep the whole arrangement for some time, and let us see what will happen inside the test tube. Okay, we have kept the whole apparatus for some time. So here after some time we are seeing that some gas bubbles are coming. See, right here you are finding that the gases are evolving. So that means the reaction has started between the sodium chloride and then concentrated sulfuric acid. So whenever the reaction has started, um, the product that is formed is one of the gas is the HCl gas. Why? Because NaCl plus H2SO4 will give rise to Na2SO4 and then HCl gas. So this is the HCl gas that is coming out. So this is a dry HCl gas which is coming out. So now what we have to do is that we have to bring a litmus paper near the mouth of the test tube. See, I told you that this is the HCl. Why? Because it is the reaction between the sodium chloride and then concentrated sulfuric acid. So this is one of the product formed. And now we are going to bring a dry blue litmus paper near the mouth of the test tube. So here this is the mouth of the delivery tube. Sorry, it's not the test tube, delivery tube. So now we'll bring a dry blue litmus paper near the mouth of the delivery tube and see what will happen. This is a blue dry litmus paper. It is a dry blue litmus paper, and the dry HCl gas is passing through the delivery tube and it is flowing through the litmus paper, isn't it? So here you have taken the dry blue litmus paper. So whenever the HCl gas is flowing through it, you are finding no change in it, isn't it? Okay. And here, while doing this experiment, we have to take another precaution. That is, you should not keep your face near the gas that is coming out of the derivative. Why? Because if you inhale them, it will be dangerous for the lungs, isn't it? So that's why don't keep uh, this delivery tube, mouth of the delivery tube near to your face. Okay, so that is another precaution which you have to take. So dry HCl gas that is coming out of the delivery tube should not be inhaled. So you keep it a little bit far and then take the test tube and then sorry, take the litmus paper and then test it with the dry HCl gas. Okay, now we'll try to do with the wet blue litmus paper. Okay, see, just now we have seen that the gases, that is a dry HCl gas that is coming out from the uh, delivery tube, and when it is passed over the dry blue litmus paper, you didn't find any change, isn't it? So now we'll try this with the wet blue litmus paper and see do you find any change or not, isn't it? So already we have noticed that this is a dry HCl gas and we have tested it for dry blue litmus paper. Now we'll bring a wet blue litmus paper near the mouth of the delivery tube. Okay, now let us bring it and see what will happen. See, this is a wet blue litmus paper. You are bringing it near the gases, that is the dry HCl gas, isn't it? We have taken wet blue litmus paper. Previously, we have taken dry blue litmus paper. You didn't find any change there, isn't it? Now we'll see what will happen here. See, the gases are flowing over the right. See, wet blue litmus paper is changing to red color, isn't it? Right. Very nice. So that means the dry HCl gas is not responding with the dry blue litmus paper, but it is changing the color of the wet blue litmus paper to red color, isn't it? So that meant this shows that so acids only in aqueous solution they produce H plus ions. So that H plus ions are they turn blue litmus acids turn blue litmus red, that we know, isn't it? So but only in aqueous solutions the acids they uh, undergo they give ions, they undergo ionization, otherwise they give ions. So acids only in aqueous solutions they produce ions. So this is the uh, test we have seen, isn't it? So now we'll record our observations. Now let us record our observation. Okay, so the first observation we have seen that, see, by bringing a litmus paper, we have taken two litmus papers, one a dry blue litmus paper and another one a wet blue litmus paper. So with the dry blue litmus paper, we noticed no change in it, no change in the color of it, isn't it? So dried litmus paper does not have any change with the uh, gases when HCl gas is passed over it. Whereas when a wet blue litmus paper is brought near the HCl gas, that is a dry HCl gas, the litmus paper has changed to red color. With the dry blue litmus paper, no change you you've found it, and with the wet blue litmus paper, it has changed to the red color. Okay, these are the two observations we have seen. Now we'll write the equation. What are the materials we have taken? We have taken sodium chloride, and then we have added concentrated sulfuric acid to it, isn't it? So, and then we have found that the reaction gave the gas bubbles, that is the dry HCl gas. So the products formed are, one is the dry HCl gas, and then this is a gas, so we have shown it the arrow mark upwards, and the material, the other one of the other substances is the sodium sulfate. Okay, so this is the equation regarding the this experiment, right? Now we'll make a conclusion. See, the HCl gas that is evolved near the delivery tube, it dissociates in the presence of water to produce the ions, isn't it? But in the absence of water, the HCl gas does not dissociate. That means dissociation of HCl molecules does not occur. Only in the presence of water. That's why we have taken wet blue litmus paper. So with that only the HCl gas responded, whereas with the dry blue litmus paper, the HCl gas does not respond, isn't it? So this shows that it dissociates in the presence of water to produce the hydrogen ions. In the absence of water, the dissociation of HCl molecules does not take place. So HCl with water, it gives H3O plus ions plus Cl minus. So H plus ions does not exist independently. They exist in the form of H3O plus, that is the hydronium ions. So H plus ions does not have independent existence. With water, it appears in the form of hydronium ions. Okay, so this is about the this lab activity. Acids produce ions only in aqueous solutions. Okay.
Let us see what is involved when water is mixed with an acid or a base.
Let's first understand what dilute and concentrated mean generally. The most important thing about these terms is that they are relative. What do I mean by relative? Here are two beakers on the screen, one on the left and one on the right, and both have 100 milliliters of some colorless solvent. Now in the beaker on the left, I add 20 milliliters of some red solute. And on the right, I add 50 milliliters of the same red solute. In this case, we say that the solution on the right is concentrated and the one on the left is dilute. We are looking at these two relative to each other. And you can see that the concentrated solution is more red in color as compared to the dilute one. This is stronger, we can say. Let me give you another example. We take two empty beakers again, both with 100 milliliters of some solution. The first beaker has 20 milliliters of solute and 80 milliliters of solvent. And the second one has 25 milliliters of solute and 75 milliliters of solvent. Which solution is more concentrated according to you? Yes, it's the second one, because the proportion of solute is more in the second beaker. Now that you know what dilute and concentrated mean, let's move on to understanding what dilute and concentrated acids and bases are. In cases of acids, water is considered to be a solvent and the acid added to the water is the solute. So we have one beaker on the screen here with some water and we add acid to it. As the amount of acid I am adding to the beaker is increasing, the solution is getting more and more concentrated. Now let me ask you an interesting question. When I'm mixing acid and water, should we add water to the acid or should we add acid to the water? To know the answer, What we should know is that the process of dissolving an acid or a base in water is highly exothermic, which means a lot of heat is generated. Now, if we add water to the acid, the heat generated may cause the mixture to splash out, which may cause severe burns. And the glass container which contains the solution may also crack due to excessive heating. You'd probably argue that the same would happen when acid is added to the water, right? Not really, and let me explain why. When we add acid to the water, the reaction will still be exothermic, but the water is a very good absorber of heat. Yes, unlike the acid, the water absorbs the heat. And that is why adding acid to water is better than doing it the other way around. But remember, the acid must be added very slowly, drop by drop, and we should constantly stir the solution. Because if we add a lot of acid directly to water, the heat generated will be so large that even water will not be able to absorb the heat.